Action. All right, welcome again Metal Fab students to another safety video. In this safety video we're going to start covering the safety around the different types of welding gases that you're going to be using. In this video we're specifically going to focus on pressure, like a pressurized vessel is really what these tanks are. The reason why that matters is because pressurized vessels, if the pressure is relieved out of them too fast, like a balloon, they become missiles. Okay, and getting hit by a balloon really doesn't hurt too bad, but getting hit by a metal tank that weighs, over 100 pounds can be fatal. So we're going to talk a little bit about the pressure of these tanks and how to safely handle them. So let's just start with a definition of air pressure first. Okay, the way we measure air pressure for this type of thing is the amount of pounds that it exerts on a square inch. So if you think about a square inch is literally about that much. It's just an inch by an inch square. And here on Earth, in the atmosphere, we actually have a pressurized atmosphere. Like if you go into space, you can't breathe because there's no air out there. Or if you go up in the mountains, they say the air is thin. It's because there's not as much air pressure in the mountains. We have 14.7 pounds of air pushing against every single square inch of our body. You've lived this way your whole life, so you've never noticed it. But if you think about the massive air that surrounds the Earth, the gravity's pulling that air down, and here where we are, close to sea level, the air pressure is greater than it would be like in the mountains, just because we have so much more air pushing down on us. So we can create pressures that are higher than 14.7 psi, and we can create pressures that are lower than 14.7 psi. Pressures lower than 14.7 psi would be considered a vacuum. We're not going to talk about that in this course because we're really not getting into vacuums. But it definitely pertains to pressures above 14.7 psi. So the kind of pressures that we're talking about here, just for an example, this large tank right here is 2,500 pounds per square inch. To put that into perspective, a basketball is 8 psi. A car tire is 40. So we're going from these things that are pressurized but relatively low pressures to things that have super duper high pressures. So if you think about something like a balloon, I probably had the balloon inflated to roughly 4 or 5 psi. Multiply that times 500, and then we have the amount of pressure that's in this tank right now. The reason why this matters is because if that pressure comes out unregulated, that tank will do the same thing as the balloon did, except to a much higher degree. It will become a missile. And the missile can go through concrete walls, it can go, outside the building, and then they can go for hundreds of feet. People have been killed by flying welding tanks, okay? I just want to make that clear. Now, different types of gases have different types of pressure. So a gas that most people are familiar with is propane. So a propane tank, and this is obviously a small propane tank, but if you were to have one on your grill, it would be the same pressure as this, or the propane tank in your backyard if your house is heated by propane. That tank is under about 180 psi. Okay, so once again, not nearly as much as this, but still 4 to 5 times as much as a car tire. If that propane tank gets punctured, it is dangerous. The tank itself is going to definitely move and could hurt somebody. Okay. Some of these other types of gases, we have straight argon here, and then we have an argon CO2 mix. These are what we call shielding gases. These gases are just like our big green oxygen tank here at about 2,500 psi. We go to this one. This is what's called acetylene. The closest thing I can relate it to is propane. It's a fossil fuel. It's relatively close to the same thing. Acetylene is going to be once again around that I believe it's 200 mark, 200 psi. So we have a vast difference between the pressures in these tanks and the pressures in these other tanks. Now, it doesn't mean that these other tanks are less dangerous because they obviously contain a flammable liquid that turns into a gas when it's exposed in the environment. But as far as a pressure standpoint, not nearly as dangerous as an oxygen tank or an argon or a CO2 tank. Okay. The most vulnerable points on the tank is the valve. If the valve were to get damaged or hit in any way, the valve could easily break off this thing. If the valve breaks off of this thing, you're going to have unregulated air coming out of this thing, and it's going to be like a missile. Okay, so that's why when we store these tanks, when they're not in use, we put these caps out over the valves so that if something were to happen, the valve won't get damaged and we won't have a situation like that. This welding card and this shielding gas here is ready for use. That's why we don't have a cap on it, because we are going to use this. Also, if you notice, the tanks are stored with chains on them. The chains are meant to keep them from tipping over. Even these back here, I know you can't see the back side of it, but both of those tanks are chained. And the chains are meant to keep the tanks from tipping over. This tank right here weighs well over 100 pounds. If you get 100 pounds tipping over, the amount of energy that's out here on this valve, if this tank tipped over and let's say this valve hit this ledge or this table, that could easily break the valve right off. And once again, we have a projectile powered by air pressure. So that's why we keep the tanks chained at all times. Even when they're in storage, Dina, would you mind scanning over here? Here we have extra tanks in storage. You can see that we keep chains on them all the time. Okay. Yeah. So that about covers this video. Safe handling practices of the gases. You know, we keep things chained and we make sure that we treat the tanks with respect when we're handling them. Okay. Thank you. We'll get you on the next one. Cut.